Alright, so starting at chapter 10, I'm just going to answer a couple of these questions, just hit a couple, and then I'll answer the rest after that. So I'm going to start with question B. If you have anything raised to a power, you're essentially, quote-unquote, distributing that. So I'm going to make sure that goes to every single thing there. So I'm going to have 8 to the negative 2, x, and when you raise powers to powers, you multiply. So 3 times negative 2 is a negative 6. And then y to the first power times negative 2 is a negative 2. Don't forget, if an exponent is negative, it's unhappy where it's at. So I'm going to move all of these guys down to the denominator. And as soon as you move them, they become a positive exponent. So this 8 to the negative 2 will become 8 squared, which is 64. X to the negative 6 becomes x to the positive 6. And y to the negative second becomes y to the positive second. But I've got to have a placeholder upstairs just to let me know that it is a fraction. Okay, letter D. Again, this guy is just unhappy where he's at. Move him upstairs. You're going to get 9x to the 6th and x to the 2nd. Those guys are multiplying, so just push them together. So 9x to the 8th. This one, multiply straight across. So 5x squared times 1 is 5x squared. 1 times x to the 6 is x to the 6th. If you have the same variable on top and bottom and they're both positive, you just say, is it top heavy or bottom heavy? Well, the 5 doesn't move, so I'm going to put him back upstairs. X to the 6 is bigger than x squared, so x to the 6 is going to go downstairs. It's going to be bottom heavy. I'm just going to subtract. 6 minus 2 is 4. And you're done. Alrighty, and looking at letter H here, if you happen to have a fraction, you can just make sure that this 3 gets multiplied by everything there. So, yeah, actually on this guy, I probably should have 2 over 4. I'm just going to go ahead and reduce that because I don't want to have to do 2 cubed and 4 cubed. So 2 over 4 is 1 over 2, I'm sorry. And then if you want to, you can move that x to the 3rd downstairs. I'm just going to leave it as is. The problem's not too different than the original, but I do want to reduce that. I don't want to have to multiply or reduce at the very end. So anywho, now I'm going to put 3 to all those guys. So I'm going to have 1 cubed, x to the negative 9, 2 cubed, and y to the 15th. Alright, well 1 cubed is just 1. 2 cubed is 8. X to the negative 9, I need to move him downstairs to make him positive 9. And y to the 15 is fine where he's at downstairs. So nothing else changes and I'm done. If you had left this as 2 cubed and 4 cubed, you would have had to have done the math and then actually reduced those things. So I didn't want to do that, which is why I changed it to 1/2. All right, and then lastly, I just want to point out, don't forget anything to the 0 power becomes a 1. So this entire thing is a 1 because 0 goes to every term. But if I had something like negative 10x to the 0, only that 0 and the x are touching. So my answer would be negative 10. So just be mindful that 0 changes anything it's touching into a 1, but it's only what it's touching directly. So in this case, it's only touching the x value there. So for number 2, it says select all the expressions equivalent to this expression here. So I'm going to go ahead and I'm going to convert this guy into, I'm just going to break him apart down to his basic elements. All right, so firstly, 8. If I have my base of 2, I want to change everything to match. So I want to change 8 into 2 to some power. Well, 8 is 2 to the 3rd power. Okay, and then 2 to the n minus 1 is the same thing as saying 2 to the n and 2 to the negative 1. In the same way that we say like x squared times x to the 3rd is x to the 5th, that's x2 plus 3. We're just breaking these things apart. So we know that if we have the same base, we just add exponents. So if I have a base with exponents added, I can just break it apart, x squared and x to the 3rd. So 2 to the n and 2 to the negative 1. Okay, so that's what that guy is. If you want to, we can clean up a little bit. So 2 to the n, and then I have 2 to the 3rd and 2 to the negative 1st. I'm going to add those exponents, giving me 2 squared. So my original expression is 2 to the n times 2 squared. Now I've got to decide what everything else is and see if it works. Okay, this one we just said we can break apart, so that's going to be 2 to the n and 2 squared. That is exactly what we just got, so that guy is an answer, that's equivalent. All right, 4 is 2 squared, and 2 to the n is still 2 to the n. 2 squared and 2 to the n, exactly what we just got. Same exact thing. All right, moving over, we have 8 to the n. I want to break this down so that he is in a variation of 2. We know that 8 is 2 cubed, but it was 8 to the n, so it's 2 cubed to the n. And now I have a power raised to a power, so I'm going to multiply. That's 2 to the 3n, which is not the same. So that is not an option. This one over here, my 2 comes down, and then this is 2 to the n and 2 to the first. Well, this one does require a little bit of cleaning up, so I'm going to go ahead and I've got 2 to the n, and how many 2's do I have? Well, I have 1 here and I have 1 there, so together I have 2 squared as well. So that guy is also equivalent. And lastly, 16 is 2 to the 4th power, 2 to the n, and 2 to the negative 2nd. Clean these guys up, I get 2 to the n, and then 4 and a negative 2 gives me 2 to the 2nd. So the exact same thing. So all of these are equivalent except for that 8 to the n. For question 3, I want to convert this exponential function into this exponential function. I essentially want to just get rid of that a value out front. So it's going to have the same base. It's going to be b to some power. I'm just getting rid of that a value. So to do that, I've got to change this 8 to have the same base. So how do I make 8 turn into 2? Well, that is 2 cubed times 2 to the n. And we just undid that. We know that we add exponents. So this is going to be 2 to the n plus 3. So same base, and then you just add the exponents you have. Okay, this one. I know that my base is 3. So I have to say 3 to what power is 1/3? Well, anything to a negative power is going to give you a fraction. So I want it to be negative, and I don't want to change that 3. So I want 3 to the negative first. That's going to basically just flip it over. Times 3 to the x, same base, so now I can just add exponents. So I'd write it as x minus 1 or negative 1 plus x. Okay, this one over here, I know my base is going to be 1/2, which this one's a little bit more complicated. Well, I'm going from a fraction to an integer. So I know I have to have a negative exponent to flip that fraction over. So if I just had it to the negative 1st power, it'd be 2. Okay, so the negative accounts for it flipping over. Now I got to say 2 to what power is 16? Well, 2 to the 4th power is 16, but 2 to the 1/2 to the negative 4th power is going to give me that actual 16 part there. So 1/2 x. I have 1/2 on both, so it's going to be 1/2. And just add exponents. Negative 4 plus x, or x minus 4. All right, so for question 4, we're working backwards. And it's kind of like what we just did on question 2. So just break this guy apart. This is going to be y equals 3x times 3 to the 2nd. And then 3 to the 2nd is 9. Also, I should have had y equals on all these guys up here. I just forgot to do that. So let's go ahead and do that. That should be y equals, and y equals. So make sure, because it should be y equals b to the x form. So I just forgot my y equals. All right. Also here, make note that you cannot multiply. This is an exponent, and so it's stuck to just the 3. I cannot do 9 times 3 and say 27. So this is my answer, and I'm stuck. Also, this would be essentially saying that I have a stretch of 9. If I were looking at this graph, it'd be stretched by 9. The original function is moving left 2 or whatever. So just be mindful that these things are separate and you cannot push them together. All right, letter B is going to be y equals 2 to the x times 2 to the negative 1st. Well, 2 to the negative 1st flips that over, so it's going to be 1/2 2 to the x. I'm sorry. And then number 5 is going to be y equals 5 cubed times 5 to the negative x. 5 cubed is 125. And this is a little bit weird. We haven't had one like this before. 5 to the negative x. Well, the negative power, this is basically like negative 1 times x. 5 to the negative 1 is going to flip that over, make it 1/5, and then still just to the x power. So that one's a little bit weird, but that would be your answer. All right, for question 5, it will be on your reference sheet, but you should know that the formula is, well, I guess y equals, but it's what? All right, for question 5, Reading through this, you should see a percent and you should see the word depreciates. It should tip you off that the equation is going to be y equals a 1 plus or minus r to the t. And depreciates means decreases, so it's going to be the minus variation. Don't forget that a is your starting value, so y equals 1500. 1, and it depreciates, so it's minus. 32% is 0.32, and then t. So my equation, when you do that, is going to be 1500, 1 minus 0.32 is going to be 0.68 to the t. So that's your equation. And then it says, how much will her computer be after 2.5 years? So just plug in a 2.5 in there. And you can use that right in the calculator. So y equals 1500, 0.68, 2.5. Plug in that straight in the calculator. You're going to get $571.96. So just be careful on that one. Depreciates means subtract. Make sure you change your percent into a decimal. So 1 minus 0.32 is 0.68. Next one, very similar. $1,000 is your starting amount and 4.5 interest. So you're going to say a equals whatever, y equals 1,000, 1 plus, because you're gaining interest, and 4.5% is 0.045 to the t. So this guy is going to be y equals 1,000, 1.045 to the t. And then how much money will you have in 10 years? I'm just going to plug in a 10 for that. So y equals 1,000, 1.045 to the 10. Plug that right in your calculator and you're going to get 1552.97. All right, question 7 has several parts. You can read through. What's the initial amount? That's just going to be that A value. So that's going to be $500. What is the percent rate of change? Well, I know it's going to be, firstly, it's going to be an increase because it's more than 1. So it's 1 plus 0.05. And I just got to change that 0.05 back into a percent. So just move it over 2 places. You're going to get 5%. What would the function be if the interest was compounded semi-annually? Well, you have to know it's going to be on your formula sheet, but your equation is A equals P 1 plus R over N to the NT. And R is your rate, so that's going to be that 0.05. N is the number of times compounded yearly, and P is the principal. So A equals, it's still going to be 500, that's a 5 there. 1 plus, and it's compounded semi-annually, which means that it's twice per year. So 0.05 over 2, and then NT is going to be 2T. And all they want you to do is they want you to just clean that up. So A equals 500. And if you type in the calculator 0.05 divided by 2, you're going to get 0.025, and you add 1 to that. You get 1.025 to the 2t. And most of these, you can just plug this little part into the calculator, press enter, and then plus 1, and you got it. Okay, the next one is compounded monthly, which means that n equals 12. Exact same equation, 500, 1 plus 0.05 over 12 to the 12t. Do the math. If you type in 0.05 divided by 12, and you add 1 to it, you're going to get 1.004 to the 12t. And last one, compounded daily, is n equals 365. So A equals 500, 1 plus, the rate's not going to change, it's still 0.05. The number of times per year is 365, 365. If you type this guy in the calculator, you're going to get a really small decimal, but you're going to get 500, 1.00, I think there might be one more, 0, 1, and then 365t. And this is going to tell you in each equation how many times it's compounded per year.